Humans not only dream of reaching the sky, but also of drilling into Earth's interior structure. To realize this dream requires continuous downward drilling until boring through the entire Earth. In 1952, the United States first proposed the Mohole project, planning to drill to the Mojave discontinuity inside Earth. In 1961, the U.S. drilled 5 deep-sea boreholes at 3,558 meters below sea level. However, within a few years, the project was terminated due to enormous financial investment, with no significant results. After the U.S. Mohole project was proposed, the Soviet Union also began their own drilling operation in 1970, which later set the world record for vertical depth. The Kola Super Deep Borehole, but the Kola drilling at 12,262 meters depth, also failed to reach the mantle due to funding and engineering problems that similarly plagued the Soviet Union. While drilling holes on Earth seems simple, this only applies to Earth's surface. The deeper into Earth's interior, the harder the rock becomes, and the more difficult to penetrate. Therefore, during Soviet drilling operations, drill bits were frequently damaged. Besides rock hardness, Earth's internal high temperature was another major problem. At depths around 10,000 meters, temperatures inside the hole reached 300,400 degrees Celsius. This required drilling with expensive specialized drill bits. But even so, frequent drill bit failures remained commonplace. In the project's later stages, drill bits needed replacement at regular intervals. At depths approaching 10,000 meters, even simple tasks like changing drill bits became time-consuming major operations, greatly delaying drilling progress. In 1992, the Kola drilling project was halted, partly due to Russia's insufficient funding, and partly because temperatures inside the borehole were approximately twice as high as expected. The project's final progress stopped at 12,262 meters depth. If we compare Earth to an egg, this depth didn't even penetrate the eggshell. Leo Sixon once conceived in Earth Canon a fictional super-solid material whose density compared to water is like rock compared to air. Therefore, the super-solid material rapidly sank toward Earth's core. Eventually, humans used this material to create conduits through Earth and reinforced the passages. But accessing Earth's interior, besides artificial drilling, could utilize naturally existing passages to Earth's interior, such as the Mariana Trench floor or volcanic interiors. From Earth's cross-section, the innermost core has extreme temperatures and immense pressure. Earth's entire mass compresses the central region. Most of Earth's gravity and Earth's magnetic field originate from the core, including the lower and upper mantle. Pressure and temperature are also extreme, but remain in a viscous state. So if future humans develop drilling technology, they would be forced to stop upon reaching this region. Unless conduits create vertical shafts, viscous material would be drilling's endpoint. From a physics perspective, if high temperature, high pressure mantle layers were reached by artificial drilling, pressure differences between surface and Earth's depths would force mantle material up through the borehole, eventually erupting at Earth's surface, creating artificial volcanic eruptions, or directly eject deep mantle layer material, forming supermantle plume events and uncontrolled supervolcanic eruptions. Impact on Earth's ecosystem would extend far beyond high temperatures, because compared to lava, volcanic ash has wider coverage and longer duration. Massive volcanic ash would spread with atmospheric movement, gradually shrouding most or all of Earth's sunlight. Sunlight would be unable to reach the surface, ultimately causing global cooling and severe cold. All Earth's life forms except humans would suffer devastation. and humans, with the biosphere severely damaged, could not survive alone. From an astronomical perspective, using downward drilling to study Earth's interior is an inefficient approach, because Earth is not special in the universe, just an ordinary rocky metallic planet. So it's easy to find in the universe the primitive state of these planets, or even their fragmented state. Astronomers even believe that Vesta in the asteroid belt is the core of a planet. By studying Vesta, we can learn the secrets of Earth's core.